Okay, so this is how we're going to do arrive. First off, this is our vehicle over here, and whenever it is outside of this radius, we're just going to apply seek. Once it becomes within this radius, which we'll define, we want to have it, if it's right here, we want to have it as the maximum velocity, because over all the way outside we want maximum velocity. So here we want maximum velocity. Here halfway across we want half of the maximum velocity. At 0 we want 0 maximum velocity. And so we just want to have this scaled. So like if distance divided by r is 1, we want to have 1 times maximum velocity. Distance of radius, if distance is halfway across radius, we want to have 0.5 times maximum velocity. And if the distance is 1/3 of radius, or roughly, we want to have this. And so basically it's desired magnitude equals distance divided by r times max velocity. And we only want to do that when it's inside of this sphere. When it's outside, we want to, when the distance is greater than the radius, we just want to run the seek, which we have already written. So let's go in and write this. And I'd suggest watching Daniel Shiffman's videos on this because he explains it more clearly than I do. So we have seek up here. I'm going to write def arrive, and we're going to pass in self, and we're going to have a target vector. Okay, so we're going to define a radius, and I'll just put 20 in. And then we want to calculate the distance between self and target vec. Okay, so if the distance is greater than r, we just want to run the seek function. And we need to pass in the target vec. Okay, and else we want to, first we need the direction vector. So the vector from here to here. So direction vec equals rs vector create. The to value is target vec, and then the from point is self.position. So this gives us the direction vector between here and here. And then we want to calculate the desired magnitude, and this is the desired magnitude down here. So let's desired mag is equal to distance divided by radius, and we're going to multiply that by self.max velocity, which is a class attribute. So it's we don't mention it here, but it's inside of the mover. Or as this is a of type mover, this class has that attribute as well. So we have that, and so to get the desired, we're going to VM vector scale to, and scales a vector to have length of len. So we're going to pass in the direction vector and desired magnitude. And once we have that, we're going to do this right here. Self-calculate and apply steering from desired. I'm just going to... So we've found the desired for our arrive function, and so we can just put this in right there, and we don't have to worry about this anymore. So calculate and apply steer from desired, throw in our desired. So let's test this, and we want to switch this out. Instead of vehicle.seek, we want to have vehicle.arrive test. Global name direction vec is not defined 214. Direction vector, oops, let's put equals in there. So okay, you can see that it's acting really weird, and that's because our maximum velocity. So if we have our max steer force, if we have a max steer force of 5, that means we have a pretty weak steer force. And so if we want to have a strong steer force, I'm just going to put 50 in. And I'd encourage you to play around with that and see how it affects the mover. So we're moving pretty fast, but we're slowing down, and eventually we will get to the center, and it will continue to, it'll keep spinning. So I suppose we could write a function in there that says once it gets within a certain distance, have it stop. I'm not going to worry about that right now, though, in case this video will get too long.